Hey everyone, I want to talk you through my long-range 4-inch build. This is my second build that I've ever done, so I'm still new to this, but I wanted to talk you through some of the issues I had, some of the choices I made in designing this quadcopter. So this is the Dave C micro long-range thing that went sort of viral a while back ago. And one of the nice things about this frame, so this is a Dave C frame. I got it from a friend. I don't exactly know where it was made, but it's along the Dave C sort of specifications with the foldable arms. One of the really nice things is the fact that it's got these lovely thick arms, but the problem with these arms now is HGLRC, I bought these lovely Spectre motors, 1404 2750 kV motors, very nice motors, and I got them because of the red accents. But one of the things is they were a little bit stingy with the screws. They gave me two sets of short, they're about not even 5 millimeters, so 3.5 to 4 millimeter screws. I think this might be a 4 millimeter thickness arm, and so I'm only getting like 0.5 millimeter of screw length out the end there, and so I need to find some screws for that. So that was a little bit annoying, but it is nice that these are nice and thick, and I've got these beautiful red accents on here which match my standoffs, so I'm really happy about that. So these props are the Gemfan 4024. They got a 1.5 millimeter thickness for the shaft, a 1.5 millimeter shaft, so I just made sure that was the correct measurement to this motor. So one of the things you'll have to make sure of is that shaft thickness is the same as the thickness of your motor. Otherwise it's either too thick or too thin, and you're going to struggle to either get it on, or you're going to have problems with them coming off too easily. All right, and then some of the TPU parts, I don't have all of them yet, so I'll link the TPU parts, but unfortunately some of them I haven't tested, so I won't be able to tell you exactly if they work or not. I've got these very, very basic TPU mounts for the camera that came with the frame from the friend that I swapped with. So I've got these very basic Immortal T mounts which came with the frame. They just pop open here like that, and then you just pop your antenna mounts in your antenna there, and I'm going to walk through how I'm planning this out as well, because one of the things as a beginner builder is the fact that a lot of guys take it for granted that they know where everything goes just sort of instinctively, but before I even put any solder to anything, I want to know where every single part is going to go, so that I can also plan what to solder when, whether I should start with the motors, or maybe there's a few parts that are going to be a bit difficult to get to once the motors are in, that sort of thing. So I'm going to go through how I did that. This is the Caddx Ant. It's a small camera, so it is lightweight, but it's not very popular in terms of quality and all that, but I am using the Caddx Ant here. I've got this. So what this is, it's an adapter this is a 20 by 20 screw mounts, and this adapter to I think it's a 26.5 for my AIO, my all-in-one flight controller. And this TPU mount is my GPS mount. The other TPU mounts that I will be putting on here are this one. So I'll be doing a camera mount here. So this will go in the front like that. And I'll put a camera mount here because I want to use my Caddx Peanuts on there. And that's actually it. I might print something to hold. So I've got a diversity receiver. So I might do it so that I can put the front, one receiver in the front and then one vertically on the side. But I'm going to try just use cable ties and just have it sit there. This is a Radio Master. It's not true diversity. There aren't two receivers in here. It's just two antennas that are wired into the receiver. So it just gives you more coverage. So you're going to get that sort of the donuts signal going around these, and if I put them one vertical, one horizontal, that kind of increases the coverage. There's also a theory to be made to just put them both vertically, but I'm going to put one horizontal, one vertical. So that is that. It's not true diversity. I saved a little bit of money there, but I also just thought just reduce the power load. It's not going to be a huge power load, but just minimize it a little bit. I went for the Rush FPV GPS just because I know Rush is a good brand, and I wanted to make sure that I got a good GPS. So I went for that. Now, this I actually don't recommend purely because I went for the Foxeer Reaper 2.5 watt VTX purely just because I was curious about it. So my second build, I've never used such a high-powered VTX before, and I just wanted to play around with it. So honestly, the reason for this is so that I can take this drone out to the park and do a whole lot of tests with 2.5 gigahertz. So this really isn't something that I recommend for this build because it's so big. It's not super heavy, just the feeling to my hand is not heavy. Let's just check here. 12.7 grams, that is quite a bit on a tiny build like this. But yeah, it's not massively heavy. But the one that I would recommend, if you want a high-powered VTX for this small build, I would recommend the Zeus. I think it's a 1.8 watt. I'd recommend that because it's also got a 20. That's the other reason I went for this, is it's a 2.5 watt with a 20 by 20 mount. The Zeus also has a 20 by 20 mount, but it's a lot smaller. This does fit into the frame, but it's quite a squeeze and I don't want to crimp any of the wires. So I just decided what I'm going to do is I'm going to mount it this way. And as you can see, I've got quite a lot of room to play with. That prop is not going to get anywhere near that. So I am safe. The other parts I got, this is my all-in-one flight controller. This is the GEP RC Taker, I think 35 amp. The G4 35 amp. Plenty of amps for a long-range build because I'm not planning to do any heavy flying with this. This is purely just to fly into the mountains and go into the countryside. That is what this build is going to be for. And this all-in-one flight control is ideal, except this does not have a barometer. So after reading up on it a little bit, apparently, tech has gotten a little bit better in terms of the accuracy of the GPSs and, the computerization on these. So return to home should be okay, but a barometer does improve your return to home because when this thing decides to go up and then fly back, the barometer helps know what that altitude is, whereas this doesn't have it. So I would recommend rather finding, if you're going to look at the GEP RCs, I'll put a recommendation on the screen now, an alternative to this. And then I got this. This is the HGLRC SOTA. It is an independently powered beeper, so that if you do lose your drone and you got the last GPS location and you're wandering through the forest, you will find it. Hopefully. But okay, no, so we won't get into that now. And the last thing is, I don't really want to make a big deal of this. I'll put the Banggood info in the link below. But this is a long-range antenna, but it's just a no-name brand. And I know with antennas, it's probably better to buy a high-quality brand. The wiring and everything is high quality. But I'll test it and let you know once I've done some testing if it's any good. Okie dokes. So this is my second flight. I had a few issues, and what I really have found handy is the fact if you have Android, you can simply bring a USB-C cable and use Betaflight on your Android phone. So I had a few little issues and I tweaked them, and now we are good to go. I'm using an 1100 battery, really nice GMB battery. There's a bit of a breeze, it's getting worse, so I'm hoping to get some good flight time. I'm testing the flight time because I got about 12 minutes without the HD camera. I wanted to have some analog footage for you today, but that is not going to happen because I forgot my SD card in the goggles. Then the other thing is, someone said to me use Raceband 5 to get the best long-range signal. To avoid interference, so I've done that and I'm immediately seeing a difference. Another thing is that I have, let me just check which, there you go, if you can't see my analog, but I've set a switch, so I've got 500, 1.5 and 2.5 watts set to a switch on my controller, which is really nice. And you'll see here, I am now able to dip down there. I'm starting to lose a little bit of video signal, but I've never had a drone that can do this. I'm at 1.5 watts now. Let's go up a little bit. There's probably I didn't mount the battery correctly, so I'm getting way better signal today. I've jumped up to 2.5 and that actually did nothing, but I know the spot that I'm at is quite bad with interference. How are we doing? 3.7 volts. So I'm going further today than I did yesterday. The wind is taking me now. So this drone, these motors are absolutely fantastic. Like, they are so smooth. Okay, there we go. I'm losing signal completely. Let's see. Okay, there we go. Bit of video back. I think, I'm running 2.5 watts, and when the signal does get good, it gets really good. So I think it's more interference. I'm in Wi-Fi bubbles. So I'm heading back slowly. I did test GPS rescue, and that is working. What else? I'll put some analog footage from yesterday just to show you my OSD, because I've got it set up quite nicely with all my GPS info. Got an arrow pointing home, got my distance in the corner, got my link quality, which I don't think is actually working, got my GPS coordinates so that if I go down, I can just check on my goggles what my GPS coordinates were, and I can then find it on Google Maps. The timer on the right is timer 2 on the OSD, which times the flight from arming. So I've done 4 minutes now. I'm a bit of a wimp. I don't know why I came back. What else can I tell you about the drone? This little antenna that I put on, little budget antenna, is not bad at all. I could feel I'm flying with the wind now. This Reaper, the Foxeer Reaper, sure, this drone is a lot louder than my baby ape. You can hear it now, and it's quite far away. This Foxeer Reaper is not, like, it seems quite susceptible to interference. Like, now I'm running 2.5 watts, and I'm still getting a fair amount of breakup. Obviously there's Wi-Fi bubbles here as I fly past the houses. But let's just see now. Okay, what am I? I'm 500 meters away. Let's dip down to these trees and let's see what happens. I know these are pretty dry trees, but when trees are like wet trees, then you get, whoop, there we go. I've lost signal. Let's go up. Now, so, it's not like completely fail-safe penetration here. 3.6 volts left. The flight characteristics of a drone like this is very floppy. So don't expect, like, ripper flight performance, which is really, it's weird if you're used to like a park flyer that does acrobatics, but for this, knowing the fact that the floppiness is adding to my flight time, it's a nice feeling. Like, you just drop off the throttle, reduce your pitch a little bit, especially when you can feel the wind pushing a little, and then you just ride the wind. It's really nice and really relaxing. I spent an entire weekend setting up beta flights on this. Like, I really put my all into it. I made sure that I had all the bits and pieces set up. I found a motor mix from Dave C. I copied the Flywoo Explorer PID tune, and I just learned as I went along. Everything I didn't understand, I just Googled it, and I made sure that everything was set up. Like the motors, I didn't realize, because I turned the flight controller, the motors were all in the wrong orientation. So I just did the motor orientation wizard in Betaflight, and that sorted that out. And then my battery goes up. I've still got 3.59 volts. 3.5 is when I need to land. And I've got 7.36 minutes on the clock. These motors are so nice. It's noisy, but it's not that noisy. It's a very quiet day. Like, so quiet here. 3.55 volts, so we're heading to the end now. So I've done 8 minutes so far. And there's a fair amount of wind. So I think on a very calm day, I'm going to get easily 10 minutes on this Okay, it's telling me low battery. We've gone to 3.47 all of a sudden. I think I'm fighting the wind there. But on a calm day, I think I'm going to easily hit 10 minutes, where the battery did just suddenly drop. But anyway. So 8.4 minutes, not fantastic. I do have the HD camera on it. Another note is this is way easier to land than any of my other cheap drones. 8 minutes, 57 seconds. And I must say, nothing was really that difficult to install. I mean, the most difficult thing was assigning a switch to switch the VTX power on this, because I've got Tramp RC on there. That was the most difficult thing to do. Everything else was basically just wiring, and the soldering pads on this flight controller are just atrocious. But other than that, really nice.